Shano Shanartha to all of you. Welcome to Photon Educare. Myself, Dr. Veeresh Kalkori. Since from 18 years, we have been producing various medical seats and as well as engineering seats, particularly NIT and IIT. So far, IIT you can consider this as JEE Mains and JEE Advanced. So if they clear JEE Advanced, they will go for IIT. If they go for JEE Mains clearance, they will get seat in NIT colleges. And one more medical stream, that is NEET. So far we have produced 200 plus high merit medical seats and IIT and NIT inclusive 155 plus. Clear? So now in today's class, I have an 18 years of experience in teaching various competitive examinations like NEET, JEE, Karnataka CET, okay, and other Olympiad examinations. So coming to this, part, clear? So I am discussing today electric charges and fields. So as you know that when you take a matter, okay, so this is the substance. So this matter is consisting of large number of atoms. For example, when you are taking wall, so that this wall is made from bricks, okay. So bricks are systematically arranged one by one like that. So similarly, in matter, what we found that in systematic arrangement of atoms, that we call it as a crystal lattice. What do you call that? Crystal lattice. So one such atom I will take, okay. So atom is in spherical shape, alright. So central part of the atom is called as nucleus. Central part of the atom is called as nucleus, and then so electrons are revolving around the nucleus. This is the orbit of the nucleus. Let's say here are the electrons, okay. So you can take an example of this is one electron, 2, 3, 4, and this is again one more electron. Like that we have number of electrons which is revolving around the nucleus, okay. So if I say this is the last orbit, okay, this is the last orbit. So this orbit we call it is valence orbit, or you can say the electrons present in the valence orbit is called as valence electrons, or these electrons are also named as free electrons, okay. So these free electrons plays important role for the conduction of electricity. So now in this chapter we are not talking about the motion of charges. Now we are interested with the electrons, okay. So these electrons, when they are at rest, then what are the important properties and how it behaves, that property we want to study here. Clear? So now coming to the part, I'll directly move toward this. So as I told you, this matter is composed of what? Matter is composed of atoms. So central part of the atom is called as nucleus, and inside the nucleus there are two important fundamental particles. They are called as protons and neutrons, and electrons were revolving around the nucleus. So as far charge concerned, you know, what is meant by this charge? See, as you know that when you are talking about the matter, yes, we are very familiar with mass. Mass is the fundamental property of matter. Without mass, no body is existing. So that is why, how we can say mass is the fundamental property of matter. Similarly, charge is also fundamental property of matter. And you can say that it is an intrinsic property. Intrinsic means the inherent property of the material. For example, if I say the body is a charged, this body is charged. How do you say that this body is charged? Whenever you add some charged particles, so directly I will come to charged particle means what? Say for example, these are the two atoms. Okay, they are very close to each other. Okay, so this is the last orbit. I will take an example of this electron. Clear? So here is the electron, and this electron, what will happen? At room temperature, at normal room temperature, it will be transferred to next atom. It will be transferred to next atom. So like that, what happens? Again it will transfer to next atom. So at room temperature, what will happen? The transformation of electrons takes place from one atom to another atom. One atom to another atom. This is what? Internal property of the matter. When you are talking about the system, this is the system, or you can say the matter or body. So that body is considered as a system, and in which this system or a matter is consisting of large number of such atoms in which electrons were moving. So this is one case. And another case is, for example, you say for example this is the wool and this is the glass rod. Okay, or you can say this is silk cloth and this is glass rod. When glass rod is rubbed with the silk, what happens? Whatever the charges are there in the glass rod, that is transferred to silk. So that means what the charge is making difference here. See, it's very simple and very simple concept. I'll explain. When you are coming to the body, okay, so as I told you, if this is the silk cloth, and if this is the rod, glass rod, okay, so this glass rod, when it is rubbing with the silk, what will happen? When it is rubbing with the silk, so whatever the number of electrons are there from the glass rod, that will shift to silk. Obviously it will transfer to silk. So once the glass rod is losing the electrons, let's say for example in the initial case, so this is having 10 electrons, glass rod is having 10 electrons. Okay, similarly silk is also having 10 electrons. Both are having same number of electrons, let's say. Now what will happen? So this glass rod, as soon as it is transferring the electrons, let's say 5 electrons it has transferred, then how many electrons remain here after transformation? 5 electrons. Now what is the total number of electrons here? So 5 electrons plus earlier 10 electrons. Now the total number of electrons is 15 electrons. Clear? See, understand the concept. By understanding the concept only, you can able to solve the numerical problems. Don't go directly numerical problems. By knowing the formula, if you try to solve the problems, you can solve some simple problems. But to solve higher order problems, then we must and should have the crystal clear concept. Clear? So now what will happen? So this is losing the electrons. How many electrons it is losing? Glass rod is losing 5 electrons. And remained electrons is 5 electrons. So the body which loses the charges, that is called a positively charged body. What do you call that? Positively charged body. What do you call such kind of bodies? They are called as positively charged body. That means glass rod becomes positively charged here because it has lost 5 electrons. And now similarly, this silk has got 5 more additional charges. Earlier it was having 10 electrons. Now after adding 5 more electrons, what happens here? So total number of electrons is 15. Now if the number of electrons are more than the positive charges, what will happen? That body is considered as a negatively charged body. It is clear that the process of losing and gaining of electrons is called as charging a body. What is charging process? Charging is nothing but either it can lose the electron or it can gain the electron. So this process we call it is a charging of a body. A body can be charged either by taking the electrons into it or giving the electrons to another body. Clear? So that means charges are transferred from one body to another body. Remember, here charges means I am talking about the free electrons, electrons present in the outermost orbit of the atom. So that is why we call those are free electrons, because it is easily removed from the last orbit by giving certain minimum amount of energy. By rubbing is nothing but what? You are supplying certain amount of energy so that electrons from one body to another body it is going to transfer very easily. Clear? So now coming to another aspect. So as I told you, this charge is an intrinsic property or fundamental property of the matter. Fundamental property of the matter. So now how this charge is measured? So what is the measurement of charge? You know, water, it is measured in terms of liter, or mass is measured in terms of kilogram, and then you can go for measurement of temperature as a Kelvin. So like that, how does this charge is measured? Charge is measured in terms of a unit called as coulomb. In terms of unit called as coulomb. So now, before that, this body charge can be represented as Q, small q, or you can say capital Q. If a body is having N1 protons, if a body is having N1 protons and N2 electrons, then total charge on the body is represented as Q is equal to, so N1 into E plus of minus N2 into E. See, in this case, for arbitrary purpose or for arbitrary case, then we consider protons are positively charged and electrons are negatively charged. This is an arbitrary, and we have given the sign convention for proton and electrons. And however, neutrons are electrically neutral. Neutrons are electrically neutral. So protons are positively charged, electrons are negatively charged. Are you clear? So now, if the body is having N1 number of electrons, N1 number of protons. So N1 is number of protons and N2 is number of electrons. Then what is the total charge of the body? We are adding that. So Q is equal to N1 into E, where E is called as intrinsic value and it is fixed. For example, if I talk about the body, okay, this body is having a Q amount of charge, that is written as Q is equal to NE. Q is equal to N into E. So what does this N is indicating? N is indicating number of electrons. What does N is indicating here? Number of electrons. Number of electrons. Clear? And E is its intrinsic value. Every electron has its fundamental value, and that is called minus 1.6 into 10 power minus 19 coulomb. So this is the intrinsic value of the electron. And similarly, for proton also it has the same value, but we will take it as positive 1.6 plus 1.6 into 10 power minus 19 coulomb. So electron is minus 1.6 into 10 power minus 19 coulomb, proton is plus 1.6 into 10 power minus 19 coulomb. Are you clear? So this is what charge of the electron and proton. So now what I am doing, I am considering a body. This body is having N1 protons and N2 electrons. Then what is the total charge of the body? So the total charge of the body can be written as Q is equal to N1E plus of minus, this minus sign is indicating charge on the electron is negative. So now what will happen here? Q is equal to N1E plus into minus minus N2E. Then what is common here? Q is equal to N1 minus N2 into E. So this is the total charge of the body. Total charge of the body. Are you clear? So now let us consider. What is meaning of this coulomb. So we said that coulomb is the unit of charge. It is denoted as C. It is denoted as C. Are you clear? So now Now, in one coulomb of charge, let's see how many electrons are there. So, how many electrons makes one coulomb of charge? For example, when you are talking about kilogram, so this kilogram is made from grams. 1000 grams makes 1 kilogram. 1 kg is nothing but what? How many grams are there? 1 gram, 2 gram, 3 gram, 4 gram, like that. So 1000 grams makes 1 kilogram. Similarly, how many electrons makes 1 coulomb of charge? See, as you know that charge of the body is denoted as Q is equal to N into E. Clear? So now N is equal to, I want to calculate the number of electrons. I want to calculate the number of electrons present in 1 coulomb. So now transfer here. So Q divided by E. Now it is multiplication. If it is transferred to LHS, it will become division. So as I told you, we are taking Q as 1 coulomb of charge, and charge on each electron is 1.6 into 10 power minus 19 coulomb. Clear? So N is equal to 1 divided by 1.6 is nothing but 0.625 into 10 power. This is minus 19. Now it is taken on the numerator. It will become plus 19. So now what will happen? You can write either shifting the decimal point from here to here. Okay. So 6.25 into 10 power. So this is 18 electrons, or else you can also write N is equal to 625 into 10 power. 2 decimal point means 10 power minus 2, 10 power plus 18. This is 10 power 16 electrons. You see, such a trillions of electrons makes 1 coulomb. So 1 coulomb is very large. 1 coulomb is very large unit. So how large it is? You see, I will take one example. You come to know that. So how much is the value of 1 coulomb of charge? So usually when we are taking the problems, we use microcoulomb, nanocoulomb, millicoulomb, because of coulomb is the larger unit. Clear? Okay. So now let us take one example, one interesting example. So we have two bodies. One body name is A and another body name is B. One body name is A and another body name is B. So body A is transferring 10 power 9 electrons every second. Every second it is transferring 10 power 9 electrons. Then to have 1 coulomb of charge, to accumulate 1 coulomb of charge on B body, what is the time taken? Are you understanding my question? So very simple example. We have two bodies by name body A and body B. So this body A is transferring 10 power 9 electrons to the body B for every 1 second. That means for 1 second 10 power 9 electrons are transferred. Next another 1 second again 10 power 9 electrons are transferred to B. Then to transfer 1 coulomb of charge from A to B, see body B is acquiring 1 coulomb of charge which is transferred by body A. Then to acquire 1 coulomb of charge to a body B, so what is the time is spent, or you can say what is the time taken by the body to have such a 1 coulomb charge accumulation on it. So let us calculate. So now let us calculate the number of charges present in it. How many charges are there? See, in body B I will take Q is equal to 1 coulomb. You are going to deposit 1 coulomb of charge, and here how many charges are there? Q is equal to N into E. In body A, how many charges it is going to transfer? Q is equal to N is number of electrons, that is 10 power 9. E is charge on each electron 1.6 into 10 power minus 19 coulomb. Then Q is equal to how much it is? 1.6 into 10 power. Yes, this is 1.6, 10 power minus 19 plus, that is minus 10. So this is the charge, completely charge transferred on it. Then what we can write? You can write that, so this body is acquiring the charge. You know, this body is acquiring the charge. How much it is acquiring the charge? 1 coulomb of charge. Clear? So Q is equal to Q into T, we can write. Q is equal to Q into T. So now when you are writing Q is equal to Q by T, clear? when you are writing q is equal to q into t. So now what is the time taken here? Time taken we want to calculate, that is capital Q divided by small q. So what is the value of capital Q? That you want to deposit 1 coulomb of charge here, and then this small q just now you have calculated 1.6 into 10 power minus 10 coulomb. Clear? So T is equal to, so 1 divided by 1.6 is nothing but 0.625 into 10 power plus 10. So now if I write this as 6.25 into 10 power 9 second, this is the total time taken. This is the total time taken to transfer a charge from body A to body B. So now you cannot understand this, you cannot feel it, you can understand but you cannot feel that. So 6.25 into 10 power 9 second, if I convert that into years, how many years it will take? See, to convert from second to years, what I will do, I will divide this, 6.25 into 10 power 9 divided by, in 1 year how many days? 365 days. In 1 day 24 hours. Okay, in 1 hour how many seconds? 3600 seconds. In 1 hour 60 into 60, 3600 seconds. So on simplification you will be getting 198 year. Oh my god. To transfer the charge from body A to body B, to accumulate 1 coulomb of charge. See, for every 1 second how many electrons is being transferred? 10 power 9 electrons. Even though by transferring such a high number of electrons to the body B, to acquire 1 coulomb of charge, what is the time taken here? So T is equal to 198 years. 198 years. Are you clear? So that is why coulomb is the larger unit. Coulomb is larger unit. So now coming to the properties of charges. Properties of charges. Properties of charges. See, first of all, first property is charge is a scalar quantity. Charge is a scalar quantity. It is not a vector quantity. It is a scalar quantity. It is having a fixed value. It is having a magnitude. That is, how much is the magnitude of charge? 1.6 into 10 power minus 19 coulomb. And like charges, for example, if I take positive charge and here one more positive charge, then there will be a repulsive force between them. They won't attract. So like charges, either positive charges, or you can take negative charges. That means repels each other. So like charges repels, and if I take a like charge, unlike charges, this is like charge, either you take positive charge, there is a repulsive force between them, and either if you can take both negative, again there is a repulsive force, one is positive and another one is negative. One is positive, another one is negative. So in this case what will happen? Definitely, surely it will go for attraction. It will go for attraction. Clear? So one is positive, another one is negative. That means unlike charges attract each other, like charges repels each other. Next, coming to one more property, that is charges are additive in nature. Charges can be added. For example, when I take one system, this is having plus 5 coulomb charge, minus 6 coulomb charge, plus 2 coulomb charge. Clear? So what is the total charge on it? We will add plus 5 coulomb, plus of minus 6 coulomb, then plus of 2 coulomb, then Q is equal to 5 coulomb minus 6 coulomb plus 2 coulomb, that is 7 coulomb minus 6 coulomb, that is 1 coulomb of charge. What I mean to say, charges are additive in nature. We can add the charges like by using ordinary algebra. Are you clear? So the first property is electric charges are additive in nature. Okay, like charges repels, unlike charges attracts, and there is a conservation of charge. One more property, there is what? Conservation of charge. Charges are conserved in nature. charges are conserved in nature. See, what is this charges are conserved in nature? You might have heard this conservation of energy. Energy can neither be created nor be destroyed. Energy can neither be created nor be destroyed. So here charges are conserved means what? Charges are not possible to create. You cannot create the electron or you cannot destroy the electron. When you don't have right to create the electron, how it is possible to destroy the electrons? So that is why what we say, yes, electrons can be transferred from one body to another body by rubbing or by doing whatever the method that you apply, that you can transfer the electrons from one body to another body. Or you can say those electrons are charges. Clear? Charges can be transferred from one body to another body, but it is not possible to create the charges and simultaneously it is not possible to destroy the charges. So charges are conserved in nature. Charges are conserved in nature. Best example I will take. See, uranium, you might have heard this. It is an isotope. Uranium 92, whose atomic number is 92, mass number is 238. When uranium is undergoing disintegration process, that is called nuclear disintegration, that we will study in nuclear chapter. When this heavy uranium nucleus, when it is most unstable condition, then it will splits into its components. One such component is thorium. Okay. So after disintegration of this uranium nucleus, what we are getting? We are getting a thorium. Thorium atomic number is 90 and mass number is 234. And along with that, it will produce a helium nucleus and its atomic number is 2, mass number is 4. So how many electrons are there here? 92 electron obviously. 92 electrons are there in uranium nucleus. And here how many electrons are there? 90 electrons. And here how many electrons are there? 2 electrons. 90 plus 2, 92. That means if you add, you will get same. So here electrons were transferred. Okay, electrons were transferred from uranium to thorium, then thorium to helium. So that means if you add the total number, you are getting same number of electrons. It is clearly indicating that yes, electrons are not possible to create and not possible to destroy. Or in general what we say, charges are conserved in nature. It is not possible to create or destroy the charges. And another one more important property, that is fourth property, charges are quantized in nature. Charges are quantized in nature. Quantized in nature. What does it mean? Can I explain this? Charges are quantized in nature. See, as we have written Q is equal to N into E. This is the formula for calculating total charge on a body. Total charge on a body. For example, if you take, see here, if you take a charge of the body as Q is equal to 4.5 coulomb. Let us check it. So N is equal to Q divided by E. So this is 4.5 divided by 1.6. So what is your answer? 4.5 into 10 power minus 19 coulomb you can take charge. Clear? So 10 power minus 19, 19 get cancelled. So on dividing, you may be getting 2.8. Clear? 2.8. See this 2.8, N is equal to 2.8 is not an integer. It is like, for example, human being. Human being is a complete integral body part. So it is including head, okay, then eyes, ears, okay, hands, legs, everything. This is a complete part. You cannot say that half person is coming here, or 2.5 persons are going, or 10.5 persons are coming here. You cannot use such kind of numbers to define the particular person. Either you can say 6 persons are going, or 10 people are coming here, or 100 people were going there. So like that you will use the complete integer. Similarly, a body cannot have 1.5 electron. You cannot say that one electron is full, another electron is half. It is not like that. So what do you say? You say that the body is having complete integral electrons. Are you clear? So that means half electron is not possible to exist. So that is why charges are quantized in nature. Charges are quantized in nature. Instead of that, you can take the body is having a charge 4.8 into 10 power minus 19 coulomb. Check it whether this body is having such a charge or not. So n is equal to, again you know, q by e, 4.8 into 10 power minus 19 divided by 1.6 into 10 power minus 19, 10 power minus 19, 10 power minus 19, 16 ones are 16, 3s are. So now 3 is what? It is an integer. 3 electrons are there. 3 electrons are there. 3 electrons. Because of 3 electrons, what is the charge associated? 4.8 into 10 power minus 19 coulomb. So that means a body can have completely integral number of electrons. Complete integer. N value will be taking plus or minus 1, plus or minus 2, plus or minus 3, like that. So on. Either it is positive charge or it is negative charge, but it should have a complete integral value. Are you clear? So what we have learned? Charges are additive in nature, charges are conserved in nature, charges are quantized in nature. Like charges, yes, repels each other, unlike charges, attract each other. And charges are scalar quantity. Charges are scalar quantity. And you know, one more important property is, when charged particles were moving with certain velocity, its charge is invariant. That means the value of this charge, you know, q is equal to, if I take single electron, n into e, that is 1 is, I will take single electron, that is 1.6 into 10 power minus 19 coulomb, which is equal to 1.6 into 10 power minus 19 coulomb. This is one single charge electron. Okay, charge on single electron. So this value won't change when it is moving with certain velocity. So that is why what we say, charges are invariant with respect to its speed. With respect to its speed. When the charges were moving with certain speed or certain velocity, then what we say? We say that charge value is not going to change, charge value is fixed. Clear? So when this charge is at rest, you see another property. When this charge is at rest, what will happen? It will produce electric field. It will produce electric field. In next class we will discuss what is this electric field and all. Clear? So when the charge, same charge, when it is moving with certain constant velocity, when the charge is moving with a constant velocity, it will produce both electric and as well as magnetic field. When the charged particle is moving with a certain constant velocity, this is called unaccelerated motion. Unaccelerated motion. So there is no acceleration associated by the electron. It is moving with a constant velocity. When it is moving with constant velocity, so when the, understand the thing, I will repeat one more time. When electron is at rest, so we will get electric field alone when it is at rest. When electron is moving with a constant velocity, it is associated with two fields. One is electric field, another one is magnetic field. So when the charge is moving, it is not going to radiate energy. It is not going to radiate energy. There is no radiant energy. That means it is not able to produce the energy from it. There is no radiant energy. Clear? So same thing, when you are taking the charge, with accelerated motion. So this is a very important character. Accelerated motion. So this is called accelerated motion. Why it is called accelerated motion? Because when the velocity is variable, what will happen? It associates electric and magnetic field, and along with that, it will produce the energy. So this energy produced in the form of electromagnetic waves. This is a very, very interesting concept, electromagnetic waves. I will make you clear one more time, don't worry. So when this charged particle, let's say for example it is moving with certain velocity, 6 into 10 power 6 meter per second now initially. Later, after certain intervals of time, its velocity has been changed to, so 8 into 10 power 7 meter per second you say. Clear? So when the velocity of the charged particle or when velocity of electron is being changed, what will happen here? Yes, definitely this electron is associated with acceleration. So it has acceleration only when there is a change in velocity. We use the term acceleration to define the change in velocity. Now, initially it is having this much velocity. Later, after certain intervals of time, when it is being changing its velocity, then definitely what will happen is, yes, yeah, of course, it has acceleration. So rate of change of velocity with respect to time is called as what? Acceleration. In this case, the accelerated charged particle not only produces electric and magnetic field, along with that it will emit the energy, it will radiate the energy in the form of electromagnetic radiations. Those are called as electromagnetic waves. So that is why to generate the electromagnetic waves, accelerated charges are the source. Accelerated charges are the source. So these accelerated charges are being acting like a sources for producing the electromagnetic waves. Are you clear? Okay, very good, nice. So this is regarding what? Electrons and its properties. In next class we will discuss about examples. Are you clear? Okay, thank you.